Welcome to Knowledge Base. Let us solve this exponential equation together. We are given this exponential equation and our target is to find the value of x. Here is a condition. X is an element of the set of a real number. What it means is that the value of x we are going to get must be a real number. No complex solution is required. Now let's dive right into it. Looking at this expression, you will see that there is a similarity between this and a quadratic equation. Rightly so, we are going to form a quadratic equation from this. What it means is that we just want to make this an expression that is raised to the power of 2. This is what I mean. 2 to the power of x all raised to the power 2 minus 2 raised to the power x minus 6 equals 0. This and this are the same thing because from the power law, 2 times x will also give us 2x. So the arrangement does not matter. However, these are successfully made this equation to be quadratic. Sorry. All we just need to do is to make it simpler by replacing 2 to the power of x with another alphabet to make it a simple quadratic equation. And this is what I mean. Let k be equal to 2 to the power of x. So wherever we see 2 raised to the power x, we are going to put k there. And if we do that, we are now going to have k squared minus k minus 6 equals 0. So this is the quadratic equation that we have seen from the beginning coming from this equation. Now let's solve this quadratic equation by factorization. Factorization means you need to open up brackets. So we have one bracket here for one of the factors, another bracket here for the other factor, and it's equal to 0. K squared means we have two k's. So one k is in this bracket and another k is in the other bracket. Now, what are the factors of 6? The factors of 6 are 1 and 6, 2 and 3, right? 2 times 3 will give us 6. But you look at 2 and 3, they are going to they can combine to give you the coefficient of k, which is 1. But 6 and 1 cannot combine to give you the coefficient of k, or to give you 1, the coefficient of k. So the factors we are looking for are actually 2 and 3. How do we know if this is going to be plus or minus? And how can we tell if the sign here is going to be negative or positive? It's very easy. We know that 2 times 3 will give us 6. The coefficient of k here is negative 1. How do you combine 2 and 3 to give you negative 1? Of course, negative 3 plus 2 will give you negative 1. And of course, negative 3 times 2 will give you negative 6. What it means is that the sign here must be negative, while the sign here is positive. So we have k times k to give you k squared, plus 2 times minus 3 to give you minus 6, plus 2 minus 3 to give you minus 1. So we are very correct with the factorization. What this means is that either k plus 2 is equal to 0 or k minus 3 is equal to 0. It is only when one of the factors is 0 that we can have this equation to be 0. Now, from here, k will be equal to 3 when you transpose, or k will be equal to negative 2 when you transpose. Remember, we are not looking for the value of k, we are looking for the value of x. We only made an assumption that k is 2 raised to the power x. Now let's bring back the 2 raised to the power x into the place of k. So this expression becomes 2 to the power of x equals 3, or 2 raised to the power x equals negative 2. Remember, we are told that x is the element of a real number. Solving this equation can never give you a real solution. Reason being that it is going to resolve to a complex solution. What it means is that this equation does not satisfy this condition. So we are going to tag it invalid. What it means is that we have 2 raised to the power x equal to 3 as the only valid equation to work with. How do we get x? We have no option than to introduce logarithm. Taking the logarithm of both sides of the equation, we are going to have log 2 raised to the power x equal to log 3. The reason we are introducing logarithm is that we can never take 3 to the base of 2. Neither can we take 2 to the base of 3. So it's not going to work. We have to introduce logarithm. Introducing logarithm means this x can multiply this log 2 because the power of x can multiply the logarithm as one of the laws of logarithm. So we have x multiplying log 2 equal to log 3. To isolate x or make a subject of formula, we'd simply divide both sides by log 2. That way, we'll be left with x equals log 3 divided by log 2. If you like, you can leave your answer here. If you like, you can put your calculator here and get a decimal number. But the better way to represent this in a logarithmic form is to apply the change of base. Applying the change of base will mean that x is equal to log 3 base 2. Log 3 and this 2 forms the base of that new logarithm. That is the concept of the change of base. So this is a better representation of this expression or equation. So the value of x in the form of logarithm is log 3 base 2. And this is the answer to the question. If you want, you can take this, put this value into your calculator and get the decimal equivalent, which means x can also be written as 1.58 as the final answer to this question in the decimal form of things. So this answer is a real number. X is an element of a real number, and this is a real number because you can find it on a scale, on a number line. So this answer is valid, but this is invalid. If you have watched this video to this point, it means you enjoyed it and you equally understood it from my assumption. If you liked it, please comment on this video and share it to your learning colleagues and friends. If you are watching this video on YouTube, endeavor to subscribe to our YouTube channel for more educational content. Do follow our page on Facebook and every other platform if you are watching us from there, and that way you keep supporting Knowledge Base. Thank you for watching and hope to see you in our next video.